perhaps scenes like this should not be a surprise.
We could smell smoke. Everybody seemed to get off, but not a lot of info.
A Metro Milwaukee District North train on fire, passengers forced out in the cold. Listen to how the Metro CEO described the situation this morning.
It was a catastrophic engine failure.
And here's what we learned about that smoking train.
Engine downtime, costly repairs, poor fuel economy, and pollution control. The reason? Inefficient combustion. There is no engine, gasoline or diesel, that can burn all of the available fuel at the time that it can do the most good. That portion of fuel which remains unburned causes a variety of problems. Unburned fuel leaves behind a gummy residue called varnish. Varnish builds up on engine components, coating surfaces and plugging oil passages and filters. Varnish also prohibits proper engine lubrication by encouraging oil contamination. Partially burned fuel in the combustion chamber also collects and accumulates on the coolest parts of the chamber as carbon. Carbon forms a hardened, abrasive deposit on your engine. Just a 1/4 inch of carbon buildup acts like 3 inches of metal insulation, producing heat and poor performance. A combination of carbon and varnish in your engine reduces the efficiency and useful life of your engine. Besides wasting fuel, inefficient combustion produces exhaust emissions which are harmful to the environment. Varnish, hard carbon, high exhaust emissions, corrosion, rust, poor fuels, and water in fuel. They cost us all money. Some cause engine damage, and some are the result.
In today's diesel engines, fuel auto-ignites several degrees before the beginning of the power stroke. When the piston reaches the bottom of the power stroke, residual diesel fuel is left unburned. The unburnt fuel then gets discarded through the engine's exhaust system in the form of hydrocarbon emissions. But with hydrogen technology, H2 and O2 gases are introduced into the diesel engine's air intake before the turbocharger, which produces a homogeneous air mixture prior to combustion. Introducing hydrogen gas into the air intake of the engine creates a faster and more complete combustion. This results in a lower combustion temperature, reducing NOx production and lowering other carbon emissions. It also results in the added benefit of improved fuel economy. The faster and earlier burn in the power stroke means the fuel is more completely consumed, providing more power, resulting in less unburnt fuel exhausted as hydrocarbon emissions. Our patent-pending smart electronic control unit leverages analytics to deliver an adjustable level of H2 and O2 gases in order to provide the optimal ratio for your engine's specific needs. Using built-in cellular communication technology allows the smart ECU to track, monitor, and collect data for future carbon credits. Validated through both on-road and accredited third-party testing, our hydrogen technology has been shown to produce a reduction in fuel consumption, a significant reduction in the production of NOx, CO, CO2, and THC, and a greater reduction in particulate matter, meaning no black smoke. Diesel exhaust fluid usage is also significantly reduced, along with the particulate filter replacement period. Our hydrogen technology is designed for all types and sizes of diesel engines: on-road vehicles, reefer trailers, off-road construction, mining and forestry equipment, power generation, marine vessels, and railroad locomotives.